This video is to help you if you're at home and you're struggling with your homework. Your homework is now 1 through 6, not 2, 3, and 4 on the worksheet that I gave you on Monday. If you weren't here Monday, number 1, you should be taking these notes. Number 2, go to my website, get the worksheet that was assigned as practice, and start doing that. You do not have to write these notes, but if you weren't here Monday, you should. If you were here Monday and you don't feel comfortable with the material, you should write the notes as well, because that'll just help you remember. Okay, so let's take a look at this first example. Sorry that it's already partially worked out. I just keep getting interrupted. I've been interrupted about 4 times, so I'm trying to get this done and just try to make it the best possible. So here we go. Here's the first example. It's example 3. We did 2 in 3rd period, and this is the 3rd one. Just going through the steps. We need to factor and cancel this, okay? So I can take an x out on top, a 4x out on bottom, and then I can factor the top. So it factors in x plus 1, x minus 1. All right, and then I can cancel the x's. So this is what I'm left with. Now this is very important because now I'm only using this function. I'm not going to use this one anymore because the whole is an unnecessary part of the function that I needed to cancel out. Okay? Now the whole is whatever you cancel, that is what you set equal to 0 for the whole, and I'll explain what that looks like later. Okay? So basically we factor and cancel first, then we identify our whole, whatever you mark out, set it equal to 0, and it was x, so set x equal to 0. Alright? Pause this if you have to take notes. And zeros. Now we know how to find zeros because we've done that before. We set the top of the function equal to 0, so the x minus 1 and the x plus 1. These are my 2 zeros. Vertical asymptotes. I set the bottom equal to 0. Notice the bottom is 4 times x minus 2, but since it's factored, I could just do the x minus 2 equals 0. So x equals 2. Alright, next, horizontal asymptotes. This was in these directions are in the notes. You better find those notes because you're probably not going to remember how the horizontal asymptotes work without them. So, since the degree of the top was 2, and I know that might be confusing because it's 1 and 1 here, but you need to look here. Look at this degree right here and not these 2 degrees because, see, that's x squared. And when you multiply them, they're going to be x squared. So basically, you know that they're x squared. So the degree of the top is 2. You got that. The degree of the bottom is 1 because x is to the first power. So dt is greater than db. Well, in that case, there's no horizontal asymptote. Okay, and we talked about horizontal asymptotes about a week ago, and we've been practicing them. So, and if you forget, so go back to your notes and look at that. All right, now I'm going to set up my table. In order to set up my table, I need to graph my zeros, my vertical asymptote, even my horizontal asymptote, except there isn't one. So here I have these 2 zeros and this vertical asymptote. So I need a number here, 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 and probably a couple out here because I don't know how this is going to curve. So this is what I chose. I chose -3, 0, 1.5, and 2. And I probably need to pick another number, so let's go ahead and pick let's pick something further out there, like 6. Okay? Now I've got my trusty calculator. I'm going to plug in these values into the function. Okay? Now, I'm going to do it the old school way. I'm just going to plug it in the top, plug it in the bottom, and then go with it. So -3 cubed minus -3, -24, okay? And then 4, -3 squared minus 8, okay? 60, okay? So let me double check my calculations. Those seem to be right. All right, so then I do -24 divided by 60. Okay, this is -0.4. All right, some of these I'm going to do in my head because y'all don't want to watch me do all these calculations all day long. So Now, notice I accidentally plugged into the original function. I just made a boo-boo. I actually want to plug it into the function I created earlier, which is this right here. So I want to plug it in there, but it's okay. I know I'm going to get the same answer here as I would here, but not with the whole. Because if you plug in all zeros, you get 0 over 0. But you can plug in the whole here. You can plug it in there. So let's do it there. And I'm going to do this in my head just for speed's sake. So I'm going to get rid of the calculator. Okay, so 0 minus 1 is negative 1 times 1 is negative 1. Okay, so negative 1, 0 minus 2 is negative 2 times 4 is negative 8, negative 8. So that's about 0.125. Okay, and then, well, I need the calculator for the 1.5. So minus 1 times 1.5. Okay, and then 4. Okay. So negative 6.25. Negative 0.625. All right, let's do 2. 2 you can do it in hand. 2 minus 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 2 minus... Uh-oh, I got 2 minus 2. Well, why did I pick 2? See, that's silly. All right, good learning point right there. I shouldn't have picked 2 because it's the vertical asymptote. Okay, I should have picked 3. Okay, so 3 minus 1 is 2. 3 plus 1 is 4. 2 times 2. 3 minus 1 is 2. 2 plus 1, or 3 plus 1 is 4. 4 times 2 is 8. 3 minus 2 is 1. 8 over 4. Okay, so 8 over 4 is 2. 6. 6 minus 1 is 5. 6 plus 1 is 7. So 5 times 7 is 35. 6 minus 2 is 4. 4 times 4 is 8. So we got 25 over, no, double check. 35 over 16. Yeah, 35 over 16. What is that? 2.18. So a little bit over 2. Okay. So, all right, all these I'm going to plot except for the whole I'm going to plot with a circle. So this is a special one. Okay. Let's go ahead and we're going to go over 0, up 0.125. Really, I just say up a little bit because you really can't get accurate with those decimals. You're going to put a circle, all right, up a little bit. And so obviously this is curving, it's at the top of the curve. So obviously, well, let's plot our other points. That'll help us. So negative 3, negative 0.4. I just say down a little bit, and that's a regular point. Okay, and then 1.5, negative 6.25. So that's down a little bit more. All right, I can obviously see where this curve is going. Okay, it's just curving, and I don't need to be 100% accurate. I just need to make sure it's curving in the way it's supposed to, and it's not going to change directions and go back up. So I know I'm going to get as close to the asymptote as I can without actually touching it. So there's that side of the graph. Next side of the graph, we go to these points. Over 3, up 2. And over 6, up 2.18. So it's up a little bit more. That really doesn't tell me much. So I'm going to plug in 2.5, okay? I don't know what the graph is doing right there, not really. So, okay, 2.5. And then y. So let's plug it in. 2.5 minus 1. And 2.5 plus 1. Enter. 5.25. Okay. And then all over 4. 5 minus 2. Okay. All right. So 5.25 divided by 2. 2.625. That helps me a little bit. So I'm going to go over 2.5 up 2.625. And that means that point is a little bit higher. So that helps me a little. I can see that, I can now pretty much see what this curve is going to do. Okay, but I can actually plug in another one. Let's just plug in another one, just to be sure, like one way out there. Let's plug in 8. All right, so 8. Well, I don't have to do that. Clear. All right, so 8 minus 1 is 7. 8 plus 1 is 9. Enter. 63 divided by 4 times 8 minus 2 is 6. That's 24. Okay, so 63 divided by 24. 2.65. Okay. So so it's gone up a little bit more. So 2.625. So 8, 2.625. So out here it goes up just a little tiny smidgen more. I know, that's kind of bad. Okay, and there you go. You pretty much know how this is going to curve. It's got to curve up. And just try to be as smooth as possible. I know I'm not. And it's got to go on that way. Okay? Alright, so cool. We're done. Here's a pan out. You can pause it, take a look at the work. Alright? And let's move on to the next example. That did take a long time, but notice I was being really thorough. When I kind of knew how the graph curved, I kept plugging in points to make sure. And that's what took a whole lot of time, is I kept plugging in points to make sure. Plus I was explaining all the steps and whatnot, which actually takes more time than working it out. Let's see how long the next one takes us. Alright, so example 4, x cubed minus 6x squared plus 8x. All over that. We're going to factor and cancel it first. I'll be sure to write smaller. So up here I can take out an x. Oops. It's x squared minus 6x plus 8. And down there I can take out a 4. X squared. Okay, minus 2x minus 8. And I can factor those trinomials now. So that's x minus 4, x plus 2. Oh, that's on bottom. Doggone. On top, that's x minus 4 and x minus 2. Okay, so that's it on top. And then on bottom, that's your x minus 4, x plus 2. Alright, so now we cancel what we can, and there, got a special canceling tool right there. And there, now we're left with okay. Now I'm just going to leave it like that. That's what I have left over. Now my whole, I go to this orange slash, and it's the x minus 4. So that's what cancels out. That's my whole. So next I go to my zeros, and I'll pan out. Zeros is the top, and that's what's left on the top. So x and x minus 2, so I set x equal to 0. And I set x minus 2 equal to 0. And so x equals 2. Okay. Vertical asymptote, you set the bottom equal to 0, not the forward, just the x plus 2, so x plus 2 equals 0. So x equals negative 2. Horizontal asymptote, I take a look at the degree. Now once again, this is 1 and this is 1, but let's have some common sense. Those two really make x squared. So the degree on top is 2. Degree on bottom equals 1. Okay? And when I say degree, I mean the highest exponent. So you'll multiply and that'll make x squared, you'll multiply and that'll make 2x. So you have the x squared and the x to the first power, but that's really the highest exponent is going to be x squared. Okay? So here we have, once again, dt is greater than dB. So no horizontal asymptote. Okay? All right, so we're going to go ahead and plot zeros and vertical asymptote. So the zeros are 0 and 2. Vertical asymptote's at -2. And no horizontal asymptote. So here I'm going to go ahead and pick my points pretty quickly. I'm going to pick -3 over here. Right here I'm going to pick -1. I'm going to pick 1. And I'm going to pick, let's see, what should I do? I'll do 4. Remember, I have to include the whole. The whole was at 4. So since I have 4, I'm going to go ahead and put h next to it, and I'm good to go. So I'm going to work these mentally so we don't spend so much time typing on the calculator. So when x is -3, that's -3 minus 2 is -5 times -3 is 15. -3 plus 2 is -1, so -1 times 4 is -4. So we get -15 over -4. Double check. Yes. All right. Which is the same as 15 divided by 4 is 3.75. -1. -1 minus 2 is -3 times -1 is, wait a second, I goofed. That one on top, that's -5 times -3 is positive 15 divided by -1 times -4. So positive 15 divided by -4 would be actually -3.75. I caught myself. -1. -1 minus 2 is -3 times -1 is positive 3. -1 plus 2 is positive. So that's positive 3 on top, positive 4 on the bottom. And 3 divided by 4 is 0.75. 1 minus 2 is -1 times 1 is -1. 1 plus 2 is 3 times 4 is 12. So what did I have on top? -1. -1 on top and 12 on the bottom. So what's that going to be? I don't know. -0.08. All right, 4, plug it in. 4 minus 2 is 2, times 4 is 16. 4, so I got 16 on the top. So 4 minus 2 is 2, times 4 is 8. Oh, 8 on the top. I always have to double check myself. And then 4 plus 2 on the bottom is 6, times 4 is 24, so 8 over 24. Okay, which is a third, so 0.33. Okay. All right, so let's go ahead and graph them. -3 over 3 down -3.75, so almost to 4. Right about there. Okay. Over 1 up 0.75. Almost 1. All right, over 1 to the right, down barely. Just barely down. And then over 4 up 0.333, which is just up just a little bit, and it's a hole. I make a big hole, but really it's very microscopic. Now, I need another point over here, so I'm going to plug in -7, or actually, let's just plug in -8. Okay, so -8 minus 2 is -10 times -8 is 80. -8 plus 2 is -6. -6 times 4 is -24. And I don't know what that is. 80 divided by -24. -3.3 repeating. Okay, so -8. Let's see. This was, what was this? This was -3.75. 1, 2, 3. I didn't really go down that far enough. on that one. Okay, and this one, -8, -3.333, so that's kind of in the same spot, just barely a little bit up above. So it looks like I'm going to have to plug in something in between, so let's say -6 or -4. Or actually, that's -4, -5 right there. Let's do -5. All right, -5 minus 2 is -7 times -5 is 35 over -5 plus 2 is -3 times 4 is -12. Let's see what we get there. 35 divided by 12, -12. Oh, that's 2. All right, -2.91. So it goes up. -2.91. Okay, so it goes up barely. But just enough. Now we see the curve, right? So we are pretty much certain that that has to curve there because it can't cross or touch the asymptote, and that's going to continue to curve there. Okay, and this is going to have to curve like so, and that's going to have to curve like so. It's gonna, maybe not that drastic, but it's going to curve that way. Okay, let's move on to the next couple. Okay. All right. So here's the next example. Go ahead and write it down. Pause the video if you wish. All right, we're going to factor and cancel this. So here we go. I can take a -3x out on the bottom. Notice taking out the -3 switched the sign, so it made the signs more similar. Okay. And cancel. And I can cancel this as well. Alright, so that's all I have left. I've got x plus 2 divided by -3. Okay, well I can actually change that. I can divide them both by -3. I'm going to split them. And that's going to change it to, that's basically, I can move the x out. Now it's just -1/3 x minus 2/3, because a positive divided by a negative is a negative. So -1/3 x minus 2/3. Okay, so we basically just have a line here with two holes actually. Okay, so we have a, now this might look confusing, okay, but it's really not. It's saying x plus 2 divided by one number. Well, you can double divide the x and divide the 2, okay? So there you go. You can do x divided by -3, which is -1/3 x, and 2 divided by 3, 2 divided by -3, which is really just a -2/3. Let's move on to our holes. Now, on the holes side of things, you have x plus 3 equals 0, because I crossed it out. So x equals -3. You have x equals 0, which is already solved. Okay, sorry, -3 there. Okay, so we have this equation. Now this is linear. Okay, so basically I don't need any of this now. Okay, all I have to do is know the slope. What is my slope? Which is m. It's -1/3. Back to 9th grade math, 8th grade math. And what is my y-intercept? Which is our b. b equals -2/3. Alright, so I'm going to start at -1/3, or at -2/3. I'm going to start at -2/3, which is right about here. and I can use my slope to go down 1 over 3. So down 1 over 3. Down 1 over 3. Okay? That's going to create my line. Alright? Or I could plug in points. I'm not going to do that because it would take too long, and you know how to do it this way, so that's easy. So basically we need to find our holes. We're actually gonna plug in our, well, we don't necessarily have to. We know there's a hole at -3. Let's go ahead and do it though. Let's plug it in. Alright, normally I plug my holes in the table. Let's go ahead and do that because that'll help us better locate my holes. Like I know there's a hole at -3, so this line is going to continue, and the hole's probably going to end up being right about there. Okay? And I know there's a hole at 0, so I can go ahead and erase that and put a hole. Okay? But just to be safe, I'm going to plug my holes in the table, so I know I marked that out. Plug in x, -3. So I'm going to plug it in there. I'm going to do this mentally so to make it quicker. -3 times -1/3 is +1. +1 minus 2/3 is 1/3. Or 0.3. Okay? And then 0. Plug in 0, I get -2/3. So my hole right here is at over 0 down 2/3. And my hole right here is -3 up 1/3, which is exactly where I thought they were going to be, except for this probably needs to move down a little bit. Okay? And there you have it. Just go ahead and graph your line. And I'm going to be butchering this line. It's hard to hold a phone and make a graph. Alright? Guys, basically all you need to remember is factor and cancel, okay? Take what you cancel, it's your holes. Then you're going to do, if it's linear, do your slope and your y-intercept. But otherwise, do your zeros, vertical asymptote, horizontal asymptote, table, and make a graph. Alright, peace.